Performance optimization involves many aspects. Some are found on the security gateway itself, and others on the security management. The following features and blades can be optimized. Network interface cards, CoreXL, SecureXL, SMT, also known as hyper-threading, multi-queue, rule-base, IPS, application control and URL filtering, and anti-bot and antivirus. To find the best practices on each of these features, please check SK98, 348. Link to the SK is found in the video description. In this video we will introduce the diagnostic and optimization of CoreXL. CoreXL is a performance-enhancing technology for security gateways on multi-CPU core systems. When CoreXL is enabled, the firewall kernel is replicated multiple times. Each replicated copy, or firewall instance, runs on one CPU core, and is complete and independent from the other firewall instances. All the firewall kernel instances in the security gateway process traffic through the same interfaces, and apply the same security policy. A dispatcher, or SND, is responsible for sending the packets to the correct firewall instance, according to its dispatching table. This is an example of the default configuration of CoreXL on a machine with 8 CPU cores. CPU core 0 and 1 will run SND, and SecureXL, on which we will discuss on the next video. 6 firewall instances are allocated to the rest of the cores, where firewall instance number 0 will run on the core with highest number, 7 in this case. It is important to note that the number of cores, which is available to CoreXL, depends on the CoreXL license installed on the gateway. In this case, there is a license for 8 cores. If, for example, the machine has 16 cores, and the license is for 8 cores, CoreXL will use only 8 cores. On the security gateway, to verify the number of cores, run the command cat/prac CPU info. The first core number is 0. The last one, core 7 in this case, is the 8 core. To configure CoreXL, run cpconfig. Option 8 in the menu is checkpoint CoreXL. Option 1 is to change the number of firewall instances, and Option 2 is to disable or enable CoreXL. The default number of firewall instances on a machine with 8 cores is 6. Note that the change will take effect after the machine reboot. After the reboot, the command which displays the status of CoreXL instances, and the number of connections passing through each instance, is fwctl multistat. The command outputs the firewall instance ID number, its status, to which CPU core the instance is assigned to, the current and PIC number of connections on that instance. With regard to the traffic distribution between the CoreXL instances, done by the dispatcher, in versions R77.20 and lower, it is statically based on the packet source IP, destination IP, and protocol. Therefore, there are scenarios when one firewall instance would handle more connection than the other instances. In R77.30, a new feature, Dynamic Dispatcher, was introduced. The feature is disabled by default, and when it is enabled, the dynamic assignment mechanism is based on the utilization of the CPU cores, on which the firewall instances are running. To check if Dynamic Dispatcher is enabled, run fwctl multiq get_mode. To enable the feature, run fwctl multiq set_mode 9. A reboot is required for the setting to take effect. To disable the feature, run the command, and set the mode to 0. Please check SK105-261 for the dynamic dispatcher limitations. Another tool to check CoreXL status and statistics is CPView. On the SIS Info tab we can see the CoreXL status and number of instances. On the Advanced CoreXL tab, we can drill down to each firewall instance view. On instances, we can activate statistics on the instance. Please note that enabling may impact the gateway performance. Press A to enable, and Y to confirm. After enabling the statistics, we can browse down, and see which connections consumes high number of CPU cycles. When done, do not forget to press A again to deactivate the statistics. Bear in mind that each firewall instance is handling different connections. There is an advanced command line utility to check or set an interface, process or kernel instance affinity to CPU core. The command is fwctl affinity. Running the command without flags will show the command help. To view the current settings we run fwctl affinity-l-a for all, -r to order by CPU, -v for verbose. Here we can see that the interfaces IRQs are assigned to core 0 and 1, which implicit that CoreXL is running on them. Firewall instances 0 through 5 are assigned to CPU cores 2 to 7. User mode processes are assigned automatically to any CPU core. Under normal circumstances we recommend to keep the automatic affinity, however, there are cases when we want to manually change it. There are two ways to change the affinity settings. One that doesn't survive reboot, and one that is persistent through the reboot. We will demonstrate both of them. The first is to use the fwctl affinity-s command. With this command the change is applied immediately. For example, consider that on this security gateway, interfaces ETH1 and ETH2 are the firewall's external and internal interfaces, and most of the network traffic is passing through them. ETH0 is connected to another network, which does not handle too much traffic. This causes CPU0 to be much more loaded than CPU1. We want to balance the load by setting CPU1 to handle ETH2 interrupts. In case CoreXL is active, we should do it using SIM affinity, but when CoreXL is not active, we will set it manually. Set the affinity of ETH2 to CPU1. Checking the setting with fwctl affinity-l. We see that now ETH1 and ETH2 are handled by different cores. The second way that sets a persistent affinity is to edit the file fwaffinity.conf in the $fwdir/conf directory. This file is read during the machine's startup process. The default setting in this file is to automatically assign the interface's IRQs. In our example, let's consider a case where the security gateway is performing heavy logging. In this case it might be needed to allocate a separate core for the FWD daemon, which performs the logging. To accomplish that, we will edit the file with VI, and add a line. N for process name, FWD, and 2 is the core number we would like FWD to offend to. Save the file. Another step we should perform is to reduce the number of firewall instances by 1 to free 1 core for FWD. We do this with cpconfig, as shown previously. We choose 5 this time. After the gateway comes up, check the current affinity with FWCTL affinity -L. We can see that FWD process is assigned to CPU2. The change we did before with FWCTL affinity -S did not survive the reboot, and ETH0 was automatically assigned by the system also to CPU2. If we would like to change it, and CoreXL is not installed, we can set also the interface affinities in the fwaffinity.conf file. We will further discuss the combination of CoreXL and CoreXL in the next videos.